This is day 6, solving logarithmic equations. Whenever you're dealing with a logarithmic equation, sometimes you have to change the forms as you would in this case to actually solve for x. So the base here would be 8. I'll put that as a base on both sides. So on the left-hand side, that's going to actually cancel out with the log base 8, and you're left with x. And on the right-hand side, you have 8 to the 4/3. Now you can simply type this into your calculator. If you want to do it by hand, you would rewrite the 8 as a base of 2, which would be 2 to the 3rd power. And now you'll multiply your exponents, so 3 times 4/3 is 4, and 2 to the 4th power is 16. But if you go back here, you can definitely type this into your calculator, and it'll spit out a 16 for you, and that's what I'd expect most of you to do. Now, there's an extra step here. You actually have to make sure that this answer works in the original problem. And what I mean by that, you can never take the logarithm of 0 or a negative number. So in this problem, x actually had to be greater than 0. Now, this answer works well with this, but sometimes they won't, and you'll have an extraneous solution. And in this case, if your only answer had been extraneous, you would have no solution sometimes. So keep an eye out for that. You actually want to plug it back in to make sure it works. Now for a problem like this, your base will be 4, and if you use that on both sides, the logarithm actually completely disappears. So you're left with x squared equals negative 6x minus 8. Now what you would do is actually get this in standard form. And I would actually use factoring to solve this particular one. So it's going to be x plus 2, x plus 4 are your two factors. And now if x plus 2 equals 0, that's going to be x equals negative 2. If x plus 4 equals 0, that's going to be x equals negative 4. Now again, you're wanting to check your answers to make sure that everything's on the up and up. So if you look at this one, that x squared has to be greater than 0. That just means x has to be a number greater than 0 because the square of even negative, or x is less than 0. So both these answers actually meet this condition because whenever I square negative 4, I will get a positive value. So that's the reason why this one works out well. You also want to check out this other one, the negative 6 minus 8. It needs to be greater than 0. So whenever I solve for it by adding the 8 over and dividing by negative 6, x has to be greater than negative sorry, that should be a less than whenever you divide by negative. My apologies. That would be 4/3, negative 4/3. Now, as I look at my two answers, both of them meet this condition as well, that they are both less than negative 4/3. So these are good answers now. Again, you could just check them in your calculator by actually taking the answers, plugging them into the original problem, make sure it works out. The calculator will tell you error if it's a value that doesn't meet that condition where it's taking the logarithm of a negative. Both of these worked. So inequalities are really just the same thing. What I'm going to do here is I'm going to put 6 as my base on both sides, so I get x is greater than 6 to the 3rd power. And 6 to the 3rd power is 216. Now, before I circle it up as my answer, let's consider, well, I'm taking the logarithm of has to be greater than 0, so x needs to be greater than 0. That actually plays well with this answer. No number that's greater than 216 is not going to be greater than 0, so this is going to be my answer. Now, looking at the next one, log base 2 of y is less than 3. Put a base of 2 on both sides. So that cancels. I'm left with y is less than 2 to the 3rd power, which is 8. Before I circle that up as my answer, I'm going to consider the fact that y needs to be greater than 0 back here. And that actually introduces a new restriction here. So while I got an answer of y is less than 8, y cannot be any value less than 8. It has to be greater than 0. So I'm going to actually tag that in. So it's only values between 0 and 8 is an important aspect on this problem. If you miss that, you actually don't get the problem right. One last thing is if your base is ever less than 1, something strange happens whenever you change forms. And that is that the sign in the middle actually flips. So it's it's greater than 1/2 to the 2nd power, which would be greater than 1/4. So you really need to watch out for that. So base less than 1 results in the sign getting flipped around. I can talk to you more in detail one-on-one if you have a question about why that's the case. As far as this answer goes, this would be the finished answer on this problem because x had to be values greater than 0 here, and this does meet that restriction. All right, going to go ahead and figure out this last one. What's going to happen is you're going to use a base of 7 on both sides, so I don't have to worry about the inequality symbol getting flipped here since it was a base greater than 1. So I'm going to have 2x plus 8 is greater than x plus 5. And just going to go ahead and solve this out, just normal, how you usually do, and minus the 8. Okay, before you circle that, consider what restrictions might have been placed on x up here. Set the 2x plus 8 greater than 0. So 2x plus 8 greater than 0. That tells me that x had to be values greater than negative 4. Now, as I look at values greater than negative 3, all those check out, so this is fine. Let's check out the other one. X plus 5 needs to be greater than 0. So x is greater than negative 5. Again, values greater than negative 3 meet this condition, so I'm going to leave this as my answer. If one of these had been higher, like x had to be greater than, say, 0, that would have actually become my new answer, that x had to be greater than 0, instead of what I got originally of x greater than negative 3. But both of these restrictions play well with what I got as an answer, so this is my answer. All right, on our last problem, you can see where I've modeled the population of payphones in this case that have been going down by 10% per year, evidently, according to this function, because they're keeping 90%. Also, there must have been 2.28 million of these things back in 1999, X the year since 1999. Now, what I'm going to do is I'm going to determine when there will be 500,000 payphones. The variable that they gave me here is P of X. And what I'm going to do is put 0.5 in for P of X. Now, why 0.5? Well, that's 500,000, so that's 0.5 million. Remember that this was in the millions. Now what I'm going to do is I'm actually going to first divide by 2.28 before I try to change my form into logarithmic form to solve for x. So let's divide both sides by 2.28. So what I'm going to have is that 0.9 to the x power equals 25 over 114. I know the calculator gives you a crazy decimal answer there. It's actually just easier if you use the fraction. All right, now I need to actually solve for x. Since x is in the exponent, you actually have to change forms to logarithmic form. X will equal a logarithm with a base of 0.9 of 25 over 114. And now I'm actually ready to just type that in my calculator. And I get x is approximately 14.4. Now my final answer here would be 14.4 years after 1999, so in 2013 would be my final answer. For part B, when will there be no payphones? That will actually never happen. If you actually do the same process of solving when you put a 0 right here, you'd have the logarithm base 0.9 of 0. And your calculator will say error because it will never get to 0 because of the asymptote. So it's never going to happen. That wraps up today's lesson. Please let me know what questions you've got. Thank you.